Okay, ladies and gentlemen, this is video number 13 on linear quadratic systems. Why I made this video is because this is essential for IM3 and pre-calc, Okay, you got to be able to solve various types of systems. So here we go. So let's take a look at this one. Being very straightforward, the thing is, we basically are going to use substitution method. Okay? And if I just minus 3x, for example, both sides of my linear equation here, notice I will get y equals negative 3x minus 12. Now I can take that negative 3x minus 12 and substitute it into the other y. So now I have negative 3x minus 12 equal to x squared plus 2x minus 6, right? And since my x squared is on the right side, I'm going to solve and make my 0 on the left side. So I'm going to go ahead and add 3x to both sides. And if you permit me, I'm also going to add 12 to both sides, just kind of like two birds with one stone, right? So let's see what happens. I've now made 3 minus 3, 0x. I have 12 minus 12, which is 0. And that's equal to x squared plus 5x plus 6. Now, we have a quadratic here, ladies and gentlemen. And you should know there are two main ways you can solve this. You can always use quadratic formula. I repeat, you can always use quadratic formula, but try to always factor. Let's see here. If I do x times x, that's x squared. If I do 2 times 3, that's 6. I can get this 5x if I do plus 2 plus 3, correct? And since it's equal to 0, I hope you realize that that right there has to be negative 2, and that right there has to be negative 3. Now, we're not quite done yet, because all we have are the x coordinates. Okay? So I'm going to take each of these here, and I'm going to plug it into my simple linear equation there that I solved for earlier. So I know y is going to be, for example, negative 3 times negative 2 minus 12. Again, I just plugged in the negative 2 first, okay? So 6 minus 12 is negative 6. So one of my answers is going to be negative 2 was x, negative 6 was y. Okay, let's do the other one. Negative 3 now is going to go in there, right? So I'm going to have negative 3 times negative 3 minus 12. 9 minus 12 is negative 3. So my other solution is negative 3 for x is negative 3 for y. So I hope I didn't make any silly mistakes. But go ahead and pause the video if you need to. Okay, so let's try another one. Now sometimes, if you notice right here, instead of y, they'll call them different functional names, like f of x is this one, g of x is this one. But remember, those are basically y's. So like this previous problem, guys, I basically will set them equal to each other. Okay? So in other words, I know x squared plus 4x minus 5 has to equal 3x plus 1. Because I'm solving a system, I want to know where they're the same, right? Where they're equal to each other, okay? So literally, they are equal to each other. So now what? Well, let's go ahead and minus 3x both sides. And again, I'm going to go ahead and also minus 1 both sides, 2 steps in 1 there. Let's see what we get. X squared, 4 minus 3x is 1x. Negative 5 and negative 1 is negative 6 equal to, that's 0, and that's 0. So I have it equal to 0. Again, I could do quadratic formula, But let's try factoring. X times x is x squared. 2 times 3 is 6. How do I get a plus 1? Well, that's a positive 3 minus 2, isn't it? Yeah, so I have it factored. It's equal to 0. So I hope you realize that that right there has got to be a 2. And that right there, what plus 3 is 0 is negative 3. Again, not quite done. Those are my x coordinates. So now I'm going to take 2 and plug it into my linear one there. And if I have 3 times 2 plus 1, 6 plus 1 is 7. So one solution is simply 2, 7. Now let's try the negative 3 in there as well. So 3 times negative 3 plus 1, negative 9 plus 1 is negative 8. So my other solution is negative 3, negative 8. So hopefully I didn't make any silly mistakes there. But there's a way we can check it. So guys, I want to show you something else. Please remember that if we were to graph our system, we actually have a graph here, as you can see. And I want you to notice what we're really looking for, and this is very important to remember. See how they cross up there? And that up there is 2, 7, you see? And see how the line and the quadratic cross down there. We're basically looking where they cross each other, right? And that point right there is negative 3, negative 8. And that happens to be exactly the two answers I got, right? 2, 7 and negative 3, negative 8. So pause the video right now if you need to. Okay, guys, let's do one more. Again, what would I do first? That's right. Let's set them equal to each other, right? We're going to go ahead and set them equal to each other. Okay, and again, we got to solve and make it equal 0. So how about if we minus x both sides and go ahead and add 5 to both sides? Okay, so if I got a little messy there, let me do that a little bit neater there. So we're subtracting x both sides and we're adding 5 to both sides. Okay, so let's see what we got. We got x squared. We got negative 7x plus 10 equal to, well, that's 0 and that's 0 as we planned. Okay, again, I could do quadratic formula, but why not factor it if we can, right? Let's try it. X times x is x squared. 10 is 5 times 2. Minus 7x is negative 5, negative 2. That means x here must be 5 because 5 minus 5 is 0. And that's telling me x is 2 because 2 minus 2 is 0. Not quite done. I'm going to take each answer. Let's plug in the 5 there. Hey, 5 minus 5 is simply 0, right? So one answer is just simply 5, 0. Okay, now let's do the 2 in there. 2 minus 5 is negative 3. So 2, negative 3 is my other solution. Again, let's check it with the graph. So if you look at the graph that was done of our system here, guys, notice here's the parabola again, right? And if you follow the line, you will notice they cross right there, don't they? And that point is 2, negative 3, isn't it? Then, notice right here, they cross again at 5, 0, do they not? And that so happens to be the same answer. 5, 0, 2, negative 3, 5, 0, 2, negative 3. Please remember and visualize this is what we're doing, by the way. We're looking to where they cross each other. Okay? But anyways, pause the video here if you need to take notes. Okay, guys, hopefully this video helps you. If I have time, I'll make one more video with a little bit trickier linear quadratics in them, perhaps. Until next time, bye.